All right, hello. I miss you guys. I wish I could make it to class today, but I can't. So, I decided to go ahead and just record this lesson for you. Go ahead and flip your books to page 242. I'll give you a second. Books to page 242. You're going to need notes. You're going to need your calculator and obviously something to write with. While you're doing that, I'm going to read. Okay? It says that in lesson 4.3, you prove triangles congruent by showing that all 6 pairs of corresponding parts were congruent. Okay? That's 3 pairs of angles and 3 pairs of sides. Okay? So all 6 pairs of parts, corresponding parts, are congruent. Okay? Today we're going to learn 2 new ways to prove a triangles, let me put an S here, are congruent. All right? This only involves 3 parts. Okay? The first way is side, side, side. Second way is side, angle, side. Okay? Both of them have 3 parts each. Okay? That's a half as easy as what we've already done. Now, I'm going to remind you about the reflexive property of congruence. If you wanted to go look, it's on page 106 in chapter 2 that we skipped. But there's not much there to help you. So this is going to help you a lot more, I think. I've drawn this little diagram here, 2 triangles, all right? So it tells us that segment EF, okay, it tells us that segment EG is congruent to segment FD because of 2 little tick marks. It tells us that segment DE is congruent to segment GF because of the 1 little tick mark. Okay, but there's one more segment that we know that's congruent to the segment in the other triangle. It's because they're sharing a side. And what I've done is I've reversed the name so you can tell. Segment EF is congruent to itself. Segment FE. Okay, they call that the reflexive property of congruence. Okay, spelled out, it's up here. Reflexive property of congruence. And you can abbreviate to this. Reflexive property of congruence. Ref prop congruent. Okay, let's look at example 1 together. Let's look at postulate 441. Okay, it says side congruent. Okay, the postulate states that if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So you can look at those 2 triangles and match up the pieces. Okay, 6 centimeters on the blue line, 4 centimeters on the red line, and 7 centimeters on the green line. Okay, the conclusion is that triangle ABC is congruent to triangle FDE. Okay, now remember, you're supposed to have matching, corresponding pieces in order. So since they started with the top of, how do I say this? They started with the side of the red segment that touches the green one. So that's where you're going to have to start in the second triangle. They started A, B, C. So they went down the red segment to B, over the blue segment to C. So we're going to start at the top of the red segment, the part of the red segment that touches the green segment. And we're going to go down that red segment from F to D, and then down the blue segment to E. So we have to name it in the same order. That's extremely important, and it will trip you up on quizzes and tests. So make note of that. All right. So let's look at example 1. It says, use SSS to explain why triangle PQR is congruent to triangle PSR. Well, let's see. Did they match up their points in order? They sure did. PQR. So it's from P to Q. It's traveling up that short side and then traveling down the long side. So then they've got to name the other triangle the exact same way, traveling down the short side and then traveling up the long side, just like they did in the first one. So it's given that segment PQ is congruent to segment PS. So what I'm going to do is I'm going to come over here and I'm going to make tick marks, okay, just like they said. It is also given that segment QR, right here, is congruent to segment SR. Okay? So let's go ahead and write those things down. I'm going to write, and they did it like this. Segment PQ is congruent to segment PS. But remember what I told you guys. You can have that because that's a segment, that's a tangible thing, or you can just do variables. PQ is equal to PS. That's a little bit easier to write. You'll find it when you check out my homework that I have both. I've kind of used them interchangeably. It doesn't really matter. But what does matter is that you do not use the congruent symbol when you're talking about variables. You use the equality symbol. You can only use congruent symbol when you're talking about a tangible thing, which is a segment. Okay? All right, so we'll say segment PQ is congruent to segment PS. They also told us what is given is segment QR. Is that the way they say it in the example? Yes. Is congruent to segment SR. Okay, that's true. Now, what's the last truth? We just went over it with the reflexive property of congruence. Segment PR is congruent to segment RP. Why? Now, I'm going to write the Y's over here. I'm going to do this in a different color. So this is because it's given. This is because it's given. And this is because of the reflexive property of congruence. Okay? Therefore, triangle PQR is congruent to triangle PSR by SSS. Okay, by side. We just proved by SSS that these two triangles are in fact congruent. Okay, so go ahead and check it out one. Okay, I want you to write on your papers the same SSS because we're learning side first, and I want you to lay it out just the way that we did up here in example 1. Okay, SSS. And while I'm doing it on my paper, on my tablet, you're going to do it on your paper, and we'll go at the same time. Then you can check your answers. All right, so it says, use SSS to explain why triangle ABC, I'm going to go ahead and write that, triangle ABC is congruent to triangle CDA. Well, I bet I know where we're headed with this, but we have to fill in the pieces. Okay? So our first side is given. Second side is given. And our third side. I'll write this in a different color. First was given, second was given, and the third one is by the reflexive property of congruence. If you got that on your own, great. Now, really the only answer here, the only two answers really, is this and this, because all of the other information was given to you. Okay, so it helps to draw out this little table, this SSS table, and say, okay, these are the things I know, and these are the reasons, these are the things I know, and these are the reasons why I know them, right? It really, really helps. Okay, and then the other part of the answer is going to be down here. Well, we know these two triangles are congruent by SSS. Okay, in fact, I would just circle that. Okay, or box that, sorry. Let's look example 2 together. No, let's not look at example 2 yet. Let's read at the very bottom of that, check it out. The very bottom of page 242. It says, an included angle is an angle formed by two adjacent sides of a polygon. What does adjacent mean? Adjacent means touching. Okay? Two touching sides of a polygon. So in this case, they're talking about segment AB and segment BC. Okay, those two sides are touching. The included angle is the angle that's made up of those two. Those two sides are making up the sides of the angle. The two sides of the triangle are making up the sides of the included angle. Okay, so AB and BC came together to create angle B. B is the included angle. All right. There was another word I came up when I was going over this a minute ago. I said enclosed angle. It's enclosed or encased, right? By that one and that one. It's just kind of this angle here is from those two sides. So that's the included angle. It's very important because the next thing we're going to learn is side angle side. Okay, so let's read at the top of page 243. It says it can also be shown that only two pairs of congruent corresponding sides are needed to prove the congruence of two triangles if the included angles are also congruent. So what did they just say? If you have these two triangles and you're told, that's fine. If you're told that you've got two sides that are congruent and two angles that are congruent, then this is side, angle, side, side, angle, side. But these tick marks and arc marks are important, and they're supposed to be in red. So let me erase all that real quick. Okay, let's look at example. No, we're still not there. Still not to example 2 yet. Let's read this postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Okay, so we're looking at triangle ABC and triangle EDF. Okay. Or is it, did I say that wrong? I sure did. EFD. I said that out of order. Okay, so the included angles here are A and E, angles A and E. Angle A is between segment AB and AC, and angle E is the included angle between the segments EF and ED. Okay? All right, so finally we arrive at example 2. It says the figure shows part of the support structure of the Statue of Liberty. Use side angle side, or SAS, to explain why triangle KPN is congruent to triangle LPM. Okay, so I've drawn the thing here, the diagram here. Okay, and we're going to mark what we know. Okay, so it's given to us that segment KP, right there, is congruent to segment LP. So there's one thing we already know about point P. It's the bisector of the segment. I'm sorry, not the bisector. It's the midpoint. Oh no. It's the midpoint of that segment. I'm sorry, my tablet's going crazy. Okay. We also know that segment NP, which is going to be here, is congruent to segment MP. Oh, look at that. We found out that P is the midpoint of that segment as well. Even though they all look, we don't know for sure that it's exact because, it doesn't tell us that. But it sure does look like there are 4 congruent segments there. However, we're going to go with 2 pairs, just like they told us to. There's 2 pairs of congruent segments. Okay, so let's go ahead and fill that in real quick. They called it KP. Oh, I wanted to change to blue. Hang on. KP is congruent. Well, they said segment KP is congruent to segment LP. I'm going to use the variables to make it easy. NP equal to MP. The tablet's going crazy on me. Okay, so already we have side and side. Now, I wish I was there with you because I would ask to see a show of hands. Who knows how to get the angle out of this guy? I hope you remember. Okay, I'm going to take you down here to the bottom and give you a little note real quick. Now remember, when 2 lines cross, there's a certain angle relationship that diagonal angles have to each other. First of all, the angle relationship is, there's a certain name for that relationship, but their relationship is that they're congruent. The name of the relationship is called vertical angles. Now don't get mixed up. Remember I told you vertical usually means up and down, but in this case, it means diagonal. Okay, so not only are these two congruent angles, and you can kind of see that, right? That's an obtuse angle. Now flip your view and see that's the same obtuse angle, right? Okay, not only that, these two are also congruent. Check out those angles. They look the same. If you were to flip your head around, it looks the same, right? So those are vertical angles. Okay, enough of the side lesson here. All right, so in this case, we know that, I'm going to mark this, angle KPN, okay, that's KPN, is congruent, okay, I'm going slowly for you guys, I'm going to do it in a different color now, to angle LPM. Okay, I started up here, I don't know if you noticed, but this whole thing has been rotated. Why? Because I have to rotate those arc marks to match up with each other. Okay, now let me step backwards and clean up stuff. Okay, this whole thing's been rotated. All right, so angle KPN is congruent to angle LPM by the, and here's our answer. Hold on. Let me actually write that in blue again. Angle KPN is congruent to angle LPM. Okay, now let's write in a different color. Well, this is a given. This is a given because remember the little tick marks. And this is because they are vertical angles. Now you're going to see in your book vertical definition of vertical angles theorem. You don't have to tell me all that stuff. Just as long as you can identify vertical angles. Vertical angles are made from two straight lines. Okay, let me do this. 1, 2, 3, and 4. 1 is equal to 3 and 2 is equal to 4. Okay, whatever those values are. And I used equal because I'm pretending like they're variables. Okay, so that's vertical angles. All right, so what can we say about this triangle? So we already did, this is kind of part of the answer because that's the one you were supposed to figure out. But the other part of the answer is triangle. How did they name it in the book? KPN. Oops. KPN is congruent to triangle LPM by, this is your second part of your answer, side angle side. Okay, it's congruent by side angle side. Go ahead and check it out too on your papers. Remember to write out side angle side, SAS. And I'm going to slowly go through it. Okay. So I figured out the sides. I figured out the different elements, right? I've got AB, the value for the segment, AB is equal to the value of DB, right? Why? Because it's given. Because they told us with arc marks. And I'll put the arc marks on here. They told us that. Okay? I know the second one, but I said arc marks. I'm so sorry. These are the segments with the little lines. Those are tick marks, but these here are arc marks. Sorry about that. They're both red. Now that means that these two angles are congruent. So it is also given to us with those little arc marks that angle ABC and angle DBC are congruent. Okay? The only one thing left to figure out really is why. Why is B? Oh, I put that wrong. Why is CB equal to BC? If you said by the reflexive property of congruence, you would be correct because they share that side. Easy peasy stuff, right? All right, let's see. Before we go to example 3, I want to see if I'm supposed to say anything else. Guarantees that if you're given the two lengths of two sides and measure the included angle, you can... No, we're not going to do a construction. Okay. Let's look at example 3 at the top of page 244. Okay, it's got a 3A and a 3B. All right, so what I've done is I've drawn to my best ability on the tablet. And by the way, I cracked my tablet today, so I have a really long spider cracks going through the tablet, which makes it hard to write. But anyway, we've got triangle UVW. So UVW, we're going in this direction. UVW. And triangle YXZ are congruent. Okay, it says show that they're congruent, even though they told you they're congruent in the bold instructions there. It's still, they're telling you to show it, right? Well, right off the bat, I just want to kind of point out to you that they gave you 3 sides here, and they gave you some information to figure out 3 sides here. Now let me step back 6 steps. By that reason, we know... I don't have any room to write this. Hold on, let me move some things around. Okay. We know that we're probably going to be using side, side. Okay? Let me even write it a little bit bigger. Side. Okay? Now, it does give you the value of x as 3. Okay? So let's figure this out. Let's just plug these in. So if the value of x is 3, I'm going to cross out this x, and I'm just going to write 3 here. Okay, 3 times 3 is 9 minus 5. I'm going to cross that out and put a 4. And then x minus 1 is 2 if x is 3. Okay, so I just traded, I traded out all of that algebra for an actual number by doing it in my head, okay? So I have 2 triangles now that both have sides that equal 2, 3, and 4. So, I mean, you don't have to really do that here because they're all givens. I mean, okay, so this is what they would ask for, right? They would say UV is equal to, that's the long side, UV, okay, I'm starting here at the end of the short side. So if this is the long side, I'm going to start here at the short side, at the y. Yx is equal to, both of them are equal to 4. So that's the long side. Let's do the short side. Let's start at y and go to z, okay? YZ. If I started here and went that way, then I want to start at u and go that way. So is equal to UW, and the short side is 2. So obviously we know our middle side is going to be 3. I'll go ahead and write that. Let's start at the long end and go towards the short end. Okay, so VW, and it doesn't matter how we write them. It doesn't have to correspond with the name of the triangle at this point. Just as long as, if I'm starting over here by the long segment at V, and I go that way towards W, and I call it VW, then I have to do the same thing. I have to start over here at the long end and go that way and call it XZ. I can't call it ZX. Okay? So that's how I would have proved all 3 sides are the same. And then I would say that these 2 triangles are congruent by SSS. I'm sorry about all the markup. I was just thinking it would be easier to show you guys, you know, how to name things if I circled and stuff. Let's look at example 3B. We've got 2 triangles here. Now, right off the bat, like I said, let's use common sense. They've given you a side. They've given you a side, and they've given you an angle. That's the point that I knew that I had to draw, that I had to draw a side angle side. Okay? That's the point that I knew. So, our example tells us that y is equal to 7. Okay, so at this point, I'm going to ask you guys to do some stuff on your calculator because I'm not going to be able to do this in my head. Thankfully, the math's already done for me. Actually, I think you might not need your calculator, actually, since we're just doing the example. Check it out. It looks simple enough. Okay, so if y is equal to 7, what is 2y plus 1? Well, 2 times 7 is 14 plus 1 is 15. So I'm gonna erase that, and I'm just gonna write 15. Well, look at that. It matches. Oops. Okay. If y is 7, then y squared is 49 minus 4y is 28 plus 3. I'm going to go ahead and erase all that. And I find out that that is, in fact, 24. Okay? Corresponding to that side. All right? And then here, this is a little degree mark, by the way. It's just really badly executed. All right, we've got y is equal to 7. So 12y plus 42, I'm going to erase all of this, does actually end up to be 126 degrees. Okay, so you can see that corresponding side. That corresponding angle. So what did they do here? It looks like they rotated, right? Just like that, with the sound effects and everything. Okay, so let's write this down. So we're going to say JG is equal to JG. I'm starting at the long side, so DE. If you don't know what I meant by that, I meant this long side here, so I'm starting at this point and going towards the shorter side. I'll start, oh no. I'll start here at this side and go towards the shorter side. Okay, so that's how I figured out how to name it. Okay, then we'll say that EF is equal to, so I'm starting at the short side and I'm going towards the long side. EF is equal to GH. Okay, they're both the same. And then I'll say that angle E is congruent to angle G. Okay, if you're wondering why I didn't say equal, this is why. Whoops, I forgot my little angle. It's because of this. I don't bother with the measure of angle E. That turns it into a variable. Okay, this is a tangible thing. That's an angle. And then the measure of angle E is the variable. I just don't bother with the little m. I feel like it's too much writing. I'd rather just do the congruent symbol. Okay, but you can do either one. And honestly, I don't mind if you say that, because I understand what you mean. The measure of angle E is equal to the measure of angle G. Okay, so how do we know that these two triangles are congruent? Well, we proved it by side angle side. Okay, let's do check it out 3 on your paper. Already you can tell we've got a side and an angle. And since we only learned 2 things this lesson, we're probably going to fill out side angle side. Okay? Tells you that the value of t is equal to 4. And I think you might be able to do this in your head. Let me do this in a different color. So you should be doing this on your paper. Now, I'm going to do a little side lesson over here. When you get to 2t squared degrees, remember your PEMDAS, okay? If it tells you that t is 4, then you know you're dealing with 2 times 4 squared. How did I know that? Because exponents come before multiplication in PEMDAS. Remember, parentheses, exponents, multiplication. All right? So whenever you see the squared symbol like that with a variable, then we know that only the variable is being squared, not the variable times something and then squared. Okay? So t is equal to 4, so that's 16 times 2, which is in fact 32 degrees. All right, if you got your side lengths at 13, you're correct. AD is equal to CD. They're both 13. Okay. Angle CDB is congruent to angle ADB. And as you can tell, there are multiple names for these, right? You can call it BDA is congruent to BDC. And those are both 32 degrees. And what's the final thing? I hope you can tell by now. Oh, that's definitely not an angle. I'll go ahead and write it the segment way. DB is congruent to BD. Why? We don't need a value. These two, we were able to figure out values, right? But this one, we don't need to know the value. It is the reflexive property of congruence. Okay? So now all of these are going to be answers, really, because you had to figure them out. All of these are going to be answers, and so will this. That's your answer. Okay? That's the end of the lesson. Your assignment is 4.4, page 245, 1 through 18. Now, you're going to have 2 days to do this. All of Wednesday, well, the rest of Wednesday, and all of Thursday. Okay? It's due by the end of class on Thursday. I almost put EOD because I'm used to seeing that, end of day. But it's not due by the end of the day. It's due by the end of geometry class. Okay? All right. I'm going to have my homework for you guys. Here's a shot of my homework for you to look at. I'm also going to send the book, and you can check your answers. But this is what I want to see. Let's do number 2 together real fast. So let's look at number 2. It's on page 245. It says, use SSS to explain why the triangles in each pair are congruent. Now, unless I'm asking you to figure something out, okay? I don't really need to know. Now, let me draw this real quick. They tell you that BC and DA are congruent because they're given. Okay, so one side is given to you. All right, and I could write it all out. BC is equal to DA, right? They also tell you that BA is congruent to DC, okay? BA is equal to DC. And that's given as well. Sorry, I mismatched these. But those are givens. I'm not really looking for that. I mean, you can fill it in if you want to, or you could just say, well, one side is given, one side is given. You can even abbreviate with a G, okay? One side is given, one side is given. And the other side, the one that you're supposed to figure out at this point, is BD is equal to DB. Why? By the reflexive property of congruence, right? So on number 2, Let me change color so you can see better. On number 2, I really only need to see that and that. You could even say this. You don't have to say the triangles are proven congruent by. You could just say by SSS. All right? If you could just circle those for me or box those for me, then we'll be doing good. Okay? Some of these I should have boxed, but I didn't. I only boxed the ends. Don't box the givens. Okay? Box the ones that you had to figure out. I hope that makes sense. All right. All right. Well, I'll see you guys on Thursday. I don't have court on Thursday, and I'll be sure to upload this and pictures of my homework to GradeLink. All right. Love y'all. I'm praying for you. Bye-bye.